Why should anyone bother learning about network protocols in today's digital world? Imagine a world where every device, every system, seamlessly communicates without a hitch. At the heart of this digital communication are network protocols, the essential rules and conventions that allow different systems and devices to speak the same language. From the foundational layers of the OSI model to the comprehensive framework of the TCP/IP stack, these protocols ensure that data flows smoothly and efficiently across the vast networks that connect our world. Understanding these protocols not only boosts your tech skills, but also opens a myriad of opportunities in the tech world. Starting at the foundation, the data link layer is where the magic begins in network communication. Dive into the world of bits and bytes at the data link layer, also known as Layer 2 of the OSI model. This layer ensures that data packets are properly formatted for physical network transmission. It's where data gets packaged into frames, complete with necessary headers and trailers for error checking and flow control. Let's explore 2 engaging projects to master this layer. First, consider the task of creating a simple Ethernet or Wi-Fi frame encoder and decoder. This project involves simulating the transmission and reception of these frames between 2 virtual nodes. It's like teaching 2 distant computers to speak the same language fluently across a crowded room filled with other chattering devices. Next, we move to developing a basic switch using MAC address tables. This project will have you building a program that intelligently forwards Ethernet frames between different ports based on their destination MAC addresses. It's akin to directing traffic in a busy city, ensuring that each vehicle, or in this case data packet, gets to the right destination without unnecessary delays. Understanding and simulating frame transmission highlights the crucial role of the data link layer in managing how data is handled over the network. MAC addresses play a pivotal role here, serving as unique identifiers that direct the traffic and keep our data flowing smoothly and efficiently. With these projects, you'll get a hands-on approach to how devices communicate and manage data at a fundamental level, climbing up to the network layer where the broad scope of networking starts to unfold. At this layer, we encounter the beating heart of Internet functionality, the Internet Protocol, or IP. IP is tasked with defining how data packets are addressed and routed across networks. It's akin to a postal system for data, ensuring that every packet knows exactly where to go and how to get there. Let's dive into the practical side. Implementing the Internet Protocol involves supporting IPv4 or IPv6 addressing systems. IPv4 uses a 32-bit address and has powered the Internet since its inception. However, with more devices than ever connecting to the Internet, IPv4 addresses are running out. This scarcity has led to the adoption of IPv6, which uses a 128-bit address, offering a virtually limitless number of unique addresses. Building a simple router offers another fascinating project at the network layer. This device decides where data packets need to go next, using a routing table to make forwarding decisions based on destination IP addresses. By simulating a router, one can delve into the core of how the Internet moves data. You could program this router to handle not just static routing paths, but also dynamic routing protocols, adapting to changes in network topology in real time. Another vital aspect of the network layer is packet fragmentation. This process breaks down large packets into smaller ones, suitable for transmission across networks with varying maximum transmission units, or MTUs. Understanding and implementing fragmentation allows developers to ensure that data packets can travel across any type of network infrastructure. These exercises will deepen your understanding of how data finds its path across complex networks. By building and testing these fundamental components, you're not just coding, you're architecting the very pathways that keep our digital world connected. Whether it's routing data packets in a simulated network or managing the complexities of IP addressing, each project at the network layer is a step closer to mastering the intricacies of network communications. Next up, the transport layer, where data starts to take a more recognizable shape. At the heart of the transport layer, we find 2 major protocols, the Transmission Control Protocol, or TCP, and the User Datagram Protocol, or UDP. These protocols are crucial for managing the way data is transmitted over a network. TCP is like a meticulous organizer, It ensures that data packets are sent and received in order, manages data flow to prevent network congestion, and checks for errors in transmission. This makes TCP ideal for applications where accuracy is critical, such as web browsing or file transfers. On the flip side, UDP is the free spirit of the two. It sends data packets without waiting for confirmation from the receiver, which can lead to packets arriving out of order or not at all. However, this makes UDP faster and more efficient for applications where speed is more important than perfect accuracy, like live video streaming or online gaming. Imagine building a TCP-based client-server application. This could be a simple file transfer service where a client connects to a server to send or receive files. The development of such an application involves setting up TCP connections, ensuring the orderly and reliable transfer of files, and handling any potential errors in data transmission. Or consider simulating a UDP application. This could involve creating a lightweight messaging app where messages are sent quickly without the overhead of ensuring they are received in the same order. Here, the focus would be on handling out-of-order messages and implementing features to improve reliability without compromising the protocol's inherent speed. By developing these projects, you would delve deep into the mechanics of connection establishment, flow control, and error handling. You would learn to manipulate how data is packaged, sent, and received at a fundamental level. By building these protocols from scratch, you'll gain insight into the reliability and efficiency of data transmission. At the peak of our protocol stack is the application layer, the closest to the end-user experience. Here, the magic of user interaction and network communication intertwines, turning abstract data into the apps and services we use every day. The application layer is where you can get creative with protocol design, tailoring solutions to specific user needs. Let's consider developing a custom protocol for a chat application. This project would involve designing message formats, setting up commands for initiating and ending conversations, and ensuring that messages are delivered in real time. This exercise teaches you about maintaining state over a stateless protocol like HTTP, a fundamental skill in network programming. Moving on, why not dive into the workings of the web by developing a simple web server and client application using HTTP? Here, you would handle HTTP requests and generate responses. This project could extend to serving dynamic content, thus exploring how web applications operate at a fundamental level. Another intriguing project could be creating a networked game. This would require handling multiple client connections, synchronizing game states, and ensuring fair play. Such a project emphasizes the importance of efficient data transmission and real-time communication in application protocols. These projects will not only enhance your programming skills, but also your understanding of how applications communicate over the internet. By building these from scratch, you gain invaluable insights into the requirements, challenges, and intricacies of software that powers real-world applications. After building each part, the true test comes in integrating these layers into a complete network stack. Integration is the art of bringing together the individual components of the network stack, ranging from the data link layer up to the application layer. This process ensures that each layer communicates effectively with the others, creating a seamless flow of data across your network. Begin by simulating network scenarios. This could involve setting up a virtual network environment where your protocols can interact as they would in a real-world setting. Use tools to generate traffic and mimic different network topologies and conditions. This allows you to see how your protocols handle stress, load balancing, and more. Next, dive into packet tracing. This involves capturing and analyzing the packets that travel through your network. By examining these packets, you can gain insights into how data is being handled at each layer. Look for any anomalies or inefficiencies that could indicate problems in your protocol implementations. Once you've gathered your data, it's time to optimize. Use your findings to tweak and refine your protocols. Identify potential bottlenecks in data flow or areas where the process can be streamlined. This might involve adjusting how data is packetized, improving error handling mechanisms, or enhancing the efficiency of data routing. Encourage a mindset of continual improvement. As you refine your network stack, always be on the lookout for ways to enhance performance and reliability. This final step is crucial for ensuring that your network protocols can handle real-world conditions effectively. Let's recap what we've explored today and why it truly matters. From the ground up, we've delved into the intricate world of network protocols, starting with the data link layer, where we learned to encode and decode Ethernet and Wi-Fi frames. We then ascended to the network layer, mastering IP addressing, packet fragmentation, and routing, essential skills for any aspiring network engineer. At the transport layer, the focus shifted to establishing connections and ensuring reliable data transmission through TCP and UDP. This is crucial for maintaining data integrity and flow across networks. Then at the application layer, we ventured into the realm of specialized protocols, crafting everything from chat applications to web servers, demonstrating the versatility and direct impact of these protocols on user experience. Each layer, each protocol brings us closer to understanding the digital threads that weave our networked world together. This knowledge isn't just academic, it's practical, equipping you to design, troubleshoot, and optimize networks. Remember, mastering network protocols not only enhances your networking skills but also prepares you for countless opportunities in the ever-evolving digital landscape.